of that, I see your live. Okay, we're live. Hey, welcome everyone to day 2 of Big Data Conference. I'm your moderator, I'm Alessandro Festa, and with me there's Josef Habdank that actually is going to present us today his great session about how to use and manage 1,000 ETL using Apache Spark. Actually, for those that don't know Josef, actually he's an expert in designing advanced analytics platforms for large-scale enterprises. It works at D6 Technology down in Denmark, and we had really great time in backstage before your session. So in a moment, I will leave to Josef the stage. Just remind you, if you have any question, feel free to post them in the chat. We will get a Q&A session at the end of Josef's session. And with that, enjoy your time with Josef. Josef, up to you for the stage and the presentation.
Yeah, thank you very much for the kind introduction. So let me just screen share the presentation. Can you see it fine? I hope you do.
Yes, absolutely, yes.
All right. So hello, everybody. Thank you very much for joining this presentation. I think it'll be great. And thanks for the kind introduction again. Let's jump right into it. So I'll be talking about how to build an advanced analytics platform using Apache Spark and what kind of things you need to think about when you're doing this kind of presentation, this kind of project to make it really long-term sustainable and working. Before I start, a few words. I assume most of you know what Apache Spark is, but just a small refresher. Basically, Apache Spark is a technology which allows you to connect multiple different technologies in the analytics world into one cohesive system, right? So it basically connects to any sort of queuing system, any streaming system, any database, or not maybe all of them, but 98%. I don't think I have ever met any that you cannot connect to, right? And it glues together this massive portfolio of technologies you have into one system, right? However, Apache Spark has its strengths and weaknesses, and I really want to describe this because the weaknesses of it are the whole reason for us to build the whole project that I'll be talking about. So where Apache Spark is strong. Apache Spark is strong because, as I mentioned before, it can work with a large variety of technologies, right? It pretty much has connectors and drivers for every single thing that you might want to use ever, right? So that is really great because that means that whatever you have already, you can start using Spark and it will just work, right? The other good thing is that it's extremely scalable for processing of large amounts of data. And when I mean extremely scalable, I mean like basically I never had reached the limits, and I've been running jobs for like on 144 workers, each of them with 32 cores, so that's like 4,600 cores, crunching petabytes of data, and I mean literally petabytes of data within an hour or so. I've been running just the biggest job I have ever run actually was 140,000 cores, the biggest one I ever run in my entire life, right? It's just the amount of data you can process is staggering, and it handles it very well because of its native support of scalability. So that is great. Basically, no matter how much data you throw at Spark, it will be able to take it, right? The other thing is it's very good in creating very complex transformations, right? So basically, Spark allows you to do way more than just SQL when you do data transformations, right? It has a lot more functionality that you can do, which is extremely useful, especially when you do machine learning, because in machine learning, you want to do something called feature engineering, which is generally quite complex transformations usually of the data. And that one in SQL normally is very difficult or impossible, but in Spark it's just built in, right? And as I said, it's applicable to very demanding machine learning. It has a lot of built-in machine learning models. So these are the kind of strengths when it really, really shines as a platform. But it actually has a lot of problems. And where are the weaknesses? It's, well, if you look at the picture on the right-hand side, right? If you're having huge amount of jobs, right? And I mean like thousands of ETLs, Spark actually doesn't have any support for that built in, right? It has very weak or non-data governance support and very weak or non-security and data security enforcement, right? And when I say governance, I mean basically to govern thousands of ETLs, right? It has almost no good orchestration tools when you have large number of clusters, especially when it comes to like if all the jobs run, each job runs on different version of Spark and has different libraries. and you have huge amounts of those. It's actually recently Databricks introduced this Spark pools, which help a bit, but nonetheless, there's very few orchestration tools. Especially when I say orchestration, I actually mean how do you create chains of ETLs, right? There's no support for that at all. You have to use other tools for that. And it has lack of good templating tools for enabling easy reuse of code. So what I mean by this, if you look at enterprise data lake, enterprise analytics platform, 99% of jobs will be primitive, like insert select or merge select, something super primitive, like very basic transformation that just move this data from one place to another. That will be 99% of your jobs. Those really complex, heavy, massive jobs, there are just a few of those that you have normally. But you have to manage those thousands of ETLs, which are very primitive, but you still need quality assurance, monitoring, data reconciliation, alerting, all these things that need to be built in there. But it has no support for that whatsoever as a native functionality, right? It has, of course, you can, of course, use some best practices of coding to replicate functionality, how to do, let's say, statistic collection across all the 1,000 jobs. But that's just you because you're a clever programmer, you're doing this. Spark natively does not support that. And again, the problem is the jobs on the left-hand side, you'll have maybe 5% of those complex, cool jobs, which are really big and really complicated. But you have 95 jobs on the right-hand side, right? So you actually have to build a lot of tools around Spark to make it a core data analytics platform framework. And again, you might think you don't have to do it, but let me give you a word of caution, you do. Right? So every single new analytics platform that you starts like the one that looks on the left-hand side. That's a lineage. So how the data sets connect. So dots, the bubbles are data sets, and the lines are ETLs, right? You start with something on the left-hand side. You maybe have 25 data sets, maybe 30 ETLs. You can completely manage it. If there are some issues, you can easily figure out what's going on, and it's just easy to control. And then 1 year later, you go to look at what you see on the right-hand side. And that's, by the way, a real picture of lineage on the data lake of one of our customers, right? Which I asked permission to show this to you. I mean, this is just insane. Look at this, right? Imagine if you have an exception, some of your job fails and starts corrupting data. Doesn't fail, it stops, because that's trivial. But imagine that there's a mistake in it, bug, and it starts corrupting data. How on earth can you control where the corrupt data flows? How do you delete what was corrupted? How do you reprocess the data if you have this mass of connectivity and you have no data orchestration tools and the data governance tools? I mean, it's just impossible. You have thousands of jobs and just something failed. Where does it connect? You have to then look through information, some documentation maybe. It would take you hours to find out what's going on, right? But you have to know this, because data corruption that corrupts your data lake because some job is failing wrongly, so it corrupts data, and then the corrupt data flows through your data lake is one of the major issues that you'll see, right? And you have to prepare yourself for that, because once it happens, you will be sleepless for a week before you fix it, right? So let's look at things that you need to think of and need to implement in order to make this work. So first problem is data governance. So, and when I say data governance, I mean basically ability to see clearly data sets, what are the contents of them, and how the ETLs connect. And how the ETLs connect, I mean, that's a lineage. We call this lineage. So basically, how all the data sets in the web of data sets are interconnected by ETLs, right? So if you just use Apache Spark, you will have lack of overview and searchability of what is actually you have there, right? Plus, if you're dealing with any privacy data, so from GDPR perspective, for the GDPR is the European law for privacy, you cannot actually avoid having data governance tools like lineage and data catalog, because in order to fulfill, there's 8 rights that you have to fulfill, but in order to fulfill 3 of them, you must have lineage. You cannot actually not have it. So the right to information, right to access, and right to be forgotten. To solve these 3, you absolutely have to have lineage. So actually, it's not only good for your data lake, but actually, it's not an option if you're dealing with privacy data. You have to have it by law, right? And so you should introduce 2 types of databases, right? First is data catalog, which basically has information about all your data sets and all your schemas, which, by the way, is important. Not only schemas how they are right now, but they should be versioned, meaning how you should have schemas how they evolved, how it looked yesterday, how it looked 1 month ago, how it looked 1 year ago, right? Because and why it's important? Well, for GPR, of course, one thing, but for data science, for example, it's critical, because if there's some data scientist who wants to do historical analysis of 2 years of data, he has to know how the column was created, how the data flow into this column, because he doesn't care about this value itself. He cares actually how it was created, because maybe there was some things done that he has to be aware of. And plus, well, maybe the data set changed 1 year ago and there is a bunch of columns which are nulls beyond 1 year. So he has to know this as well, right? Because, okay, maybe I cannot do 2 years of analysis because this one column that I'm interested in was added 1 year ago, right? So I cannot go 2 years back with this. So you have to know that both the data catalog, which is the schemas and how they evolve over time, and lineage, which is how the data is interconnected, as well with versioning, right? As well, okay, this data was created like this 1 year ago, but 2 years ago it was created like that. So data scientist, when he does historical analysis, he has to actually be able to see these things. And otherwise, how would you do it? I mean, he would be crawling, looking at Git. It would be impossible for him to find out what's going on otherwise, right? So data governance, very important. People don't think about it, but critical. Another thing that you want to be very aware of when you're dealing with data analytics platform, which you expect to grow, is your biggest bottleneck will not be the technology. It will be human resources, right? So how quickly can you scale your team? And we at DXC are doing this a lot when we join a new customer and he has his analytics platform is in total shambles. And we have to basically like fix it within 3 months or 6 months. And that means we have to scale the team extremely quickly. Like we're going to go from 3 people in the first weeks to maybe 15 people in 3 months, or maybe 50 people in half a year, or 100 people in a year. And we do that all the time. So growth of your team is actually fundamentally important, because human resources will be your choke point, not technology when you deal with analytics. So what you want to do is when you build some sort of analytics framework, you want to build it for easy onboarding of people, right? It's okay to make it suboptimal from speed performance perspective, but optimal from people onboarding perspective. It's absolutely important, because you want to be able to hand over tasks to somebody else who's more junior, and then he being able to, within 1 day, to be able to understand what's going on and work with this. If it takes somebody 3 months to understand what you did, it means what you did is useless, because you'll never be able to hand it over to somebody else. So that means you will always be maintaining this, and your team cannot grow, right? So what we did when we built our data ingestion framework is we structured it so there are 3 types of config files which you need to provide in order to create a job, and they are specifically done so that people with narrow expertise can start working with it immediately. So first thing is data shepherd, who's like a functional analyst who understands the business context and understands the data, doesn't understand the technology underneath, how things are happening, but just understands, let's say, in order to make this reporting thing for my business, I need to take order table and customer table, join them, do some transformations, and that will be able to produce me the report, right? So he looks at the data schemas and how data sets interconnect, right? So he just looks at the big picture that you saw a couple of slides before of data lake, like how does things interconnect? Does it make sense or not? But he doesn't understand technologies at all. He's like a functional analyst guy, right? So he provides the schema and lineage. Then once you have the schema and lineage, then you have a SQL engineer who doesn't care about the big picture of data lake, but he cares about, these are my input tables, this is my output table, right? And I just have to write a SQL query to make this transformation, right? Again, a junior SQL engineer could do this. He doesn't have to understand the big picture. He doesn't have to understand the business. He just has very narrow requirements. Do this transformation, go, right? And the third profile is data platform engineer, who basically works with resources. And I mean resources, I mean like databases, blob storages, and things like this. So he basically makes sure that you can map the resources properly across environments and across all your deployments. And I'll be showing how these 3 profiles fit into the framework that we did in a moment, right? All right, so another thing that you need to think of is support for multi-tenancy or multi-environment. And I'll explain how we actually solved it. This is a big one. If you deal with enterprise-grade analytics platforms, you will actually find that cost of deployment from test to production is just huge. And sometimes if a platform is done wrongly, it will maybe be double of cost of developing the component. It's sometimes just so huge of a problem. And there are best practices how you can solve this, but many people actually don't know about those. People use best practices from 10 or 15 years ago, not the most modern ones. So I'll tell you how we did it, and I think this speeds up this very well. So there are two key elements to it. First is infrastructure as a code. So, before I get to that, sorry, there's actually the multi-environment world is actually more complicated, as I just said, because very often, even if you're a startup and a small company where everybody knows everybody, at some point you likely will be bought by somebody else. Or maybe if you're a big company, likely you'll buy some other company. And what happens then? Then you end up in an enterprise which has multiple parallel IT infrastructures. And trust me, it's not that unusual. Like, if you work in a company for more than a year or two, you can expect it to be bought by somebody or you by somebody else. It's more common than you think. So you have to think not only about multiple environments like test, dev, pre-prod, and prod. You have to think of multiple IT infrastructures simultaneously that should run seamlessly, right? And you have to be able to move things across environments and across IT infrastructures to be really flexible. So now coming back to the solution, how do you solve this? Well, obvious one is infrastructure as a code. Every single thing that you deploy, never use wizards, ever. It's just, if you're just making POC, yes. But as soon as you're doing something that is actually supposed to become production at some point, so not POC, but MVP, minimum viable product, always have everything 100%, not 95, not 99, 100% infrastructure as a code, that everything is deployed by scripts, right? But the second thing that people don't think of often and don't do is resource abstraction layer. And that is basically that your system is interacting with resources through abstraction layer. So the component, let's say the ETL, doesn't know which database it's talking to. It talks to an abstract database. Let's say there will be a customer database, right? And there's abstract database there defined, and it just works as if this database was there, right? But actually doesn't know which physical database it connects to. Is it the customer dev or customer prod or customer test? It doesn't know about this. It just knows there will be a customer database, and I'm talking to this alias, and what happens behind the scenes, I don't care. And behind the scenes, you have basically a rerouting you basically have a component which allows it to point to the right database immediately. So, and you might think this is obvious, but it's not, and I'll show you why. So, the traditional way of doing this in CI/CD, CI/CD is continuous integration, continuous delivery, is by doing config files that you dynamically modify. So imagine you have 1,000 ETLs that take data from one container, which is in test resource group, test EUS01, let's say, and it puts it to some different resource group, different container in test, right? How would you do this in the kind of proper way, but it's actually not proper for real, proper 15 years ago? How would you solve this problem? Well, you have 1,000 ETLs, all of them have to have config files, and in the config file, there's a path to where to take data from and where to put it. And then each of those ETLs, you have to parameterize so that when you move from test to prod, you swap the underlying paths. And then when you go from test to prod, it just works, right? And you could think, this is the gold standard. It's actually not. That was gold standard 15 years ago, right? Because why? Because think about it. You have to parameterize every single one config file. If you have 1,000 ETLs, you have to parameterize 1,000 config files. But actually, you have only two resources that changed. Maybe there's a better way to do it, and that's what is the resource abstraction layer, right? What you do is you build your 1,000 ETLs. They have config files, but the config file points to an alias location or an abstract location, right? Let's say I'll be taking that from raw and I'll be putting it to modeled or whatever else, right? Just whatever you want to, any alias that you want to give it, right? And underneath you have a component which actually says raw is actually this test EUS01 and model is this test EUS02, and you map it dynamically on the fly, but the actual job itself doesn't see the difference. Why this is much better? It's a nuanced thing, but it will save you, I don't know, weeks and weeks of development easily. Is because in previous situations we had to parameterize 1,000 config files. Here, the config files don't change of ETLs because they point at raw, at modeled always. If it's production or pre-production, doesn't matter. It points at alias location. All you have to do is you parameterize one config file of the resource abstraction layer. Because in test, you map raw and model to one location, and in prod, you mop raw and model to different location. So you went from having to parameterize 1,000 config files because you have 1,000 ETLs to having to parameterize one config file because you just swap the underlying resource abstraction layer, but the jobs are actually identical. And by the way, if you have mapped those resources already, then you can deploy a new job on test, literally copy paste it to prod, and it will work with touching nothing whatsoever because the resources are already swapped underneath automatically. And this one trick actually saves us at least, I would say, days and sometimes weeks from each production release on a big scale system, of course, right? So, and again, it seems like a technical detail, but it's vastly important, and people don't think about it at all when they go for an analytics platform, right? They just do some code and they hope it's gonna work out, right? And I have here an example of basically how it looks. I mean, literally, we have a component which is the resource abstraction layer, and we simply have, you can see in the red square, you can see we have the storage account and blob container name, and then we have an alias. So we literally are aliasing the resources, and we're swapping those mappings. So again, modeled container will be different thing in test and different in prod, but the jobs will just point to modeled, right? They will not know actually where they're pointing in reality. All right, and the third thing you should think of is how you're going to orchestrate things. And when I say orchestrate, I mean how do you actually maintain the sequence of ETLs and how they should run in order to deliver the data that you want. So like 20, 30 years ago, what you were doing is you would say, schedule this at 9, then the next ETL at 10, and the next ETL at 11, and then by 12, your data should be there, right? And then, like, I don't know, 15 years ago or something like that, frameworks like Airflow became popular, where you can actually draw these diagrams, how things interconnect, and then you can run those. But I claim there is a better way to do it. Airflow is actually pretty good, and I know you can solve most problems with it, but it becomes still extremely cumbersome to work with. Like, I mean, if you have hundreds of elements in Airflow diagram, it becomes so hard to control it and so hard to comprehend what's going on. So even though it solves some problems, it doesn't solve all your problems when it comes to scalability. So I claim there's a better way to do it, and that is actually don't have any diagram for which ETL should go after which one, and have everything event-driven. When I say event-driven, I mean that there is some update to a table, in the database or on the blob storage, and then once the transaction to this data set was committed, so the data set is updated, you simply scan the lineage and see which ETLs are reading from this table, and you simply run those, right? And then once those ETLs write somewhere else, again, there's a new event, and no more ETLs are being triggered. And in that way, you basically organically kind of automatically resolve the problem of DAG, which is is the acyclic graph of your ETLs, right? Because you basically if there's a data set that is being updated, you know what kind of ETLs are reading from it. You simply trigger those, so you don't ever have to think of what runs when, or does it actually make problem? Is there any circular references or whatever else? You don't care about that. You simply just run your ETLs and you let the data flow through, and it kind of is organically resolved, the graph, right? So let's have a look at this, how it works. So I mentioned we have actually in our framework, we have a way of signaling when the transaction is committed. And it doesn't matter if it's the database or if it's a blob storage, we have this, right? So that basically means if there is anything written to the data set and there's a transaction committed, an event is being emitted, and then dynamically we can analyze the full lineage and find out pick out the jobs that are depending on this data set and simply trigger them and run them, right? And then what happens after that is once the job completes, it writes to some result somewhere, and then again there is an event emitted. The transaction was submitted to this new data set, and then we scan the lineage dynamically, and we trigger the jobs that are supposed to run, right? So it's pretty much as simple as that. And by the way, it works really, really great. It works really great because you never have to think of this really complex graph of interconnected ETLs. You simply need a new job, you plug it in, you say trigger when this data set is updated, and it just works automatically out of the box. You don't have to think about, okay, no, I have to run this at 7 o'clock because that data will only arrive at 9 and or at 6, so I have to wait to process, blah, 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 and all this complex stuff. You just do your job, plug it in, it just works. There is a bit of problem with it though, because there is a asynchronous fully event-driven system has a problem of flow synchronization. Flow synchronization means if you have to join, the question is, okay, how do you join? Because everything is asynchronous. So when do you trigger a job? If there are 2 data sets, when do you trigger the job? Because otherwise some data might still not have arrived, right? And that's a well-known problem in this kind of systems. But there are well-defined policies and strategies to fix that, to solve this problem. And I'll tell you about 3 of those, which are the most common ones. So first one is trigger on one, which basically means, imagine you have a fact table and dimension table, like customer and customer name, for example, right? So you want to join these, of course, right? So if you can assume that one of the tables, the dimension, for example, table, customer name, doesn't change that much, it's almost static, you can just say whenever the fact table, in this case the customer, is updated, simply trigger a job and assume that the other table is up to date, right? That's the most primitive way to solve it. You could argue it doesn't solve many problems, but it solves some. But then there is a lot of things when you have 2 fact tables. So imagine you have order and order line, right? These 2 things, I mean, they're dynamic and you have to join them exactly because when order comes in and its order lines come in at the same time, so you have to have the proper slice of data to be able to join these things, right? So for that, you will have a strategy called trigger on all, which basically means you are ETL basically tracks, or the system tracks, that which data set is updated and when. And basically, if the ETL runs, right, just need the ETL runs and processes the data, and then one of the data sets gets updated, it checks, are all the data sets that it's using updated after the last ETL run. So that's the important thing, right? So it's you have a cutoff time of you start kind of monitoring when the ETL finishes its run, and you wait until there is some transaction committed to all the depending data sets. And only once all of them have some sort of transaction committed, only then you let the job run again, right? So you run once, wait, first data set gets updated, okay, do nothing. The second data set gets updated, okay, now you're ready to run, trigger it, the ETL. Once the ETL finishes, you reset this monitoring system, and then you again wait for both to be updated. This works really well, as I said, for things like orders and orders lines. When things come in similar frequency and with similar frequency and preferably from similar source, right? Because you kind of want to join things in slices. So that's when this works very well. But when it doesn't really work well is if you have vastly different frequencies of updates between 2 data sets. So imagine you have a streaming data set, which is updated every 1 minute or every 10 minutes, and it joins with a table which is updated every 24 hours, right? If you make this trigger on all strategy, you just keep waiting with the job to run for 24 hours because the stream would keep updating as it goes forward, but the other data set will never be updated because it's every 24 hours, and then you only trigger once after 24 hours. So perhaps that's not ideal. You want the stream to go forward, right? And you just assume that the other data set is fine. But maybe you can assume it's permanently fine, right? So what you do is you do data freshness policy, what we call, which is you define the data set is fresh not only for one job run after the update, which is the trigger on all, but it's fresh for, let's say, 6 hours, right? So you define that after the transaction is submitted to the data set, it's not only okay to take it once, and this data per ETL, of course, it's okay to take it for a period of time of 6 hours or 12 hours, 24 hours. And if you have that, then if the stream proceeds forward, you'll keep be able to joining all the time until the data set is considered too old, and then you stop processing. And that is desired behavior. I know this is actually pretty complex. So by the way, guys, if you have any questions, think about them right now and write them in a moment in the chat. And or if you don't have time for that, feel free to write to me. I'll have my contact details post it right to me after. We can have a good discussion about this at some later point. All right, so next thing is quality assurance. So how do you actually make sure that the system is working correctly? And there is people normally, when they think of monitoring of systems, they only think of platform monitoring, which is look at the components, and application monitoring, which is look at the exceptions. If there are exceptions in the code, like some jobs failed. But actually, there's way more than you have to do in order to have a stable analytics platform. And basically, in Germany, there's this saying that analytics systems are like watermelons. They're green on the outside, but red on the inside, meaning all the monitoring says perfect, green, 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 no issues, but actually the system doesn't work, right? Actually inside it should be red, right? It's actually inside red, but you don't see it. And that's because you don't do enough monitoring. You don't think enough. People don't think enough. What are the best practices around monitoring systems in order to do this right? And that's what I describe here. So platform, as I said, trivial. You just look if the SQL server or whatever has enough memory, or the CPU usage is good enough, or I don't know if your Kafka is below certain threshold number hits per second or whatever else. Trivial. You have that out of the box. Application monitoring, again, exceptions. Trivial. You have that out of the box. But then imagine this. Your data flows to your analytics platform, and you're joining. And somehow this join fails, but fails in such a way that maybe the data that you're joining with is not there. And you're doing inner join. So that means that inner join filters out the data, which means that if you're missing, your dimension table is not updated, you will start losing the data. Because the join, let's say there's 1,000 rows on the input, you forward process for 1,000 rows, and then you join, and then you get 800 rows. There's no exception. SQL Server is working fine, but the job doesn't work, right? You don't deliver the value to the business that you want because you're losing the data. So you have a problem, but you wouldn't see it if you had only platform and application monitoring. You have to monitor this separately. And that's what technical reconciliation is, right? Which is on the bottom left. Is you see row counts, you mechanically count the rows as they go through the system, so that when there is something that you know I should get the same number of rows on input and output, but your number of rows drops, you can raise a problem, right? As I see here, right? You process, there's 1,000, then you validate, you invalidate 2 rows, but still if you sum up the invalid and valid, it's still 1,000. And then you go to report and you have 996. You have a problem there. You lost 2 rows. Your report is bullshit. It's not working. You cannot actually tell the business the numbers you're seeing are correct because you lost 2 rows. You have to fix this, right? But in order to fix this, you have to monitor for that. The next thing is functional reconciliation. Even if you track the rows, you still might have undetected issues. Because what if you have some UDF or some more complex transformation, which actually, again, there's a bug in it, and it corrupts the data. The rows are there, you didn't lose any rows, but you corrupted the data, right? So actually you have to now then look inside the data and verify if this is correct or not. And how you do this is called functional reconciliation. Whereas the technical is just looking at row counts, it doesn't understand the data. Functional actually understands the data. So what you do is from the source of your data sets, you pull some stats. Let's say you make sum of sales per shop per day, right? And you pull this kind of statistics report on the source, and then you pull the same statistics report on the destination, on reporting layer, right? And you compare the results, and then you see, okay, actually shop 2 has much lower sales in reporting layer than it has in source. There's a problem somewhere, and that's what you do. You have to fix it now. Then there's cost monitoring. This is trivial, I guess, but you just have to tag resources properly to allocate costs properly. It's not trivial, actually, but I don't want to talk about this now because I don't have time for that. And then the last one, which people forget about, is SLA monitoring. You can actually have a situation and everything what I described so far works perfectly, but you're still failing because your report should be there by 7 and it's not, right? So there is no problems with platform. There's no problems with application. There is no row counts lost. The functional reconciliation checks out, but the data is late, and your business starts working at 8 o'clock, and they need the report now to be productive. So you have to as well monitor the freshness, which I described in the previous slides. Is the data updated frequently enough, or was I on time when it comes to SLA? SLA, service level agreement, with my business? right? And it's important. And if you don't do all of those, you will have those watermelon situations, meaning you think it's perfect, it's green, everything was green, and then you get a phone call at 2 o'clock at night saying, hey, what the hell, my report is not working, I'm getting bollocks numbers, right? So again, you have to think of all 6 to really have a proper analytics platform which works well. All right, I have only 5 minutes more, so let me quickly go through this. I wanted to share with you some details, really briefly, how we did this all in Apache Spark, right? So as I mentioned, we have the data and lineage catalog databases, which are storing the entire ETL connectivity and all the schemas, right? Then on the top right, you see quality assurance components, where we collect statistics, basically, so row counts and all the other things we need to collect about every single ETL, on every single ETL that is running. And the important thing is what we use actually as a trick in Apache Spark is we use 2 clever tricks to get the stats out of our data sets. One is we use accumulators, which is a very powerful way in Spark to collect row counts, because you actually can, as data flows through Spark, you can do row counts without actually then running a job saying how much I inserted. You can just see as the data flows through. You can increment counters as the work is being done on the task. So you basically get statistics for free. And the second thing is you use delta lake transaction log to get how many things are updated, deleted, and whatnot. So that's just some technical trick for Spark nerds in the audience, which includes me, by the way. I'm a total Spark nerd. Then you, of course, as I said, you have the catalog, lineage catalog, data catalog is very important. Then we have resource abstraction layer, which basically dynamically mounts storage locations to the workspace. And then, of course, when we want to do some transformation, we define as a SQL statement that runs on Spark SQL. And I have still a few minutes left, so let me go through how it actually works. So if there is an event on data lake, I mentioned, you remember, it's an event-driven framework. There's an event on the data lake. There's some transaction submitted to some data set. We trigger an event. It goes to Data Factory, which then spawns the Databricks jobs in Spark and passes parameters about the event, what kind of event was triggered. Then what we do is we scan the lineage catalog and see, okay, this data set has these 3 ETLs following it. So then we spawn those tasks to do the processing. So once we are within the task that is supposed to run the ETL, first thing we do is we mount all the sources and all the destinations as Spark SQL tables, right? Because that's the easiest way to do that. When you can use them using Spark SQL. Once you have mounted those, you actually look into the catalog and you check if the data that you're seeing on a source is of the same schema as what you're expecting. Because another big problem in analytics platforms is, so if you're, let's say, getting CSV files, that someone just puts some random CSV file there, which is complete rubbish. And then if you don't check for schema drift, for schema differences, you'll actually then load the data and corrupt the later layers by loading some data which is completely rubbish into the table, right? So you have to actually do schema checks. And that's what we do. So after we mounted the tables, we do schema drift detection, which basically means we check if the schema changed, but if there's a difference between what I know I should see and versus what I see. Once we've done this, we're able to actually do the job. So then we go to our database of transformations, where we have the SQL statements effectively, and we simply run the Spark SQL. After we have finished the Spark SQL job and the job is written, we do 2 things. First, we now write the statistics into reconciliation databases, and then eventually, finally, in the last step, we trigger the dataset changed event so that next ETLs can run, right? So this is a bit of technical details for those of you who are like Spark enthusiasts and know it very well. That might have been very, very interesting to see exactly what we did to do this framework. All right, so let me summarize right now about what I was talking about. So Apache Spark is an extremely powerful technology, and I cannot emphasize how good this is. I've been using this since version 0.6 or something. It's just amazing. It's really powerful. But it's only good in doing scalable data processing. It doesn't care about the big data lake, and that's what you will be working with eventually. I mean, you never have 5 ETLs. It always becomes eventually 50 or 500 eventually, right? So it's missing a lot of features related to job and data management, like quality assurance, like monitoring, like lineage catalog, data catalog, all these things. So, and in order to survive long term, you have to think about these as early as possible, right? You have to think of these as early as possible, because otherwise you accumulate so much technical debt that you will not be able to do any work. A lot of our customers come to us, to DXC, saying, hey guys, we're wasting, our platform is so poorly developed that our development team, which is maybe 15, 20 people, are constantly only handling tickets. There's no spare time to actually do any development for new products. They just continues to maintain. Why? Because they haven't thought of the right analytics platform best practices at the beginning. And then the technical debt grows and grows and grows, and it just eats up all your time eventually, and you have no time to do actually new work. And Apache Spark doesn't help you with this. You have to think of these things yourself. So, because otherwise you will, again, never be able to do any progress, and management will be extremely unhappy, right? And they'll not even understand why this is the case. Well, why half a year ago you were still good and now you're not, right? And this is pretty much it. So my recommendation is think about the best practices I just talked about as early as possible, and it will save you a lot of headache later. All right, that was it, what I had to ask. Please start posting questions if you want. And meanwhile, you're doing this, I just want to mention, do you want to work with cutting-edge Apache Spark and Azure projects? We're hiring. Come and work for us. We need data engineers, DevOps engineers, data scientists, pretty much everybody. And if you want to work in this cool platform that I built with my teams, write to me directly. There's my email there. Or else just look for the jobs at our careers website. We're hiring. We're a huge company. We have openings. I don't know. I have thousands of openings or hundreds of openings continuously open for analytics platforms. So we will have place for you. Come and work for us. You will not regret it. We're doing some really awesome, really awesome stuff. All right. And with that, thank you very much. Now we can open to questions.
Well, thank you very much, Josef. I think it was really great presentation. Really enjoyed it. Actually, I learned it a lot. Thank you for that.
All right, thanks.
Cool. So let's see if there's any questions in the chat on the Q&A. Don't be shy. I see there's a lot of people watching us right now. Actually, that I can understand it because it was absolutely great.
Thank you. Great.
So, well, while we're waiting for question, I have a small question for you.
Mm-hmm.
Maybe someone of the attendees actually they'd like to start with Spark and everything that you actually described. What would be your recommendation after your thought?
Yeah. So I mean, to be honest, and it's not a paid advertisement, but basically use Databricks. They're extremely good, and they're cross-platform, so they can be deployed on-prem if you have big deployment. Mm-hmm. They can be deployed on AWS and Azure, so it's cross-cloud. It has huge amount of tutorials. I'm good friends with Spark, with Databricks, by person, the founder even and stuff like that. They are really doing well, very easy to onboard you, right? So that if you want to go very fast, you have no problems with DevOps, with cluster management, stuff like that, and they are very easy environment to work with. And again, so that's my recommendation. But again, read about best practices. Don't just invent things on your own. There are people who have been doing analytics for 50 years now, and there are a lot of best practices how to do things. And please read about those, because you'll shoot yourself in the foot one year down the line, right? And actually,
I think you gave a great advice, anyways, because I'm also like, if there's a tool actually that works, why not use it? Yes. So if an expert like you recommend that tools, why not using it?
Yeah, exactly. Spark is great, but it's great for what it's good for.
Yeah.
That was my second slide about this, right? But it has a lot of its own weaknesses, right? So which you have to think of, right?
Yeah.
So.
We got an answer. Yeah. We got a question. Sorry. So. A couple of questions.
Now they're popping up. People are.
Yeah.
So we have 1 more minute, so I can quickly answer this. Yeah. So I can tell you what we did, right? There are a couple of things. So in Databricks specifically, because we're running Databricks, you have this mounting of data sets. So because the question is, sorry, could you please provide more insights in how to build the resource abstraction layer, as you mentioned? Yeah. So what we do is, since you can mount underlying data sets into Databricks file system, what we do is we simply in test mount bunch of containers as mount raw layer, mount, model layer, mount, reporting layer. And if you go to production, you have different workspace, and you simply under the same paths mount different containers. So your jobs are running on the URLs within the Databricks, but they actually point to different places depending on which workspace you're at. That doesn't work if you work with Spark or Kafka, sorry, with SQL or Kafka or other resources. That works only for blob containers. So for that, we had to do some tricks and automatic path figuring out and rerouting and stuff like that. But actually, for blob storages, Databricks actually has a clever tool that if you use it right, it will just do it for you. One more.
You have another? Yeah, you have one question if you want to pick it up.
Okay, let's go for it. This is one more question. If I understand correctly, you spoke about inferring data lineage from ETL. Do you have recommendations how to do that? No, we don't infer the lineage because it's not the right thing, I think, to do. You could do it, but then you will have a false belief that you have everything, and you not have everything, right? So actually, what we do is we have a requirement that every single ETL you create has a CI/CD like a approval step that you have to post lineage into lineage database. It's a mandatory thing, and in that way we make sure that basically you cannot make commit to Git without actually updating the lineage database, and that's how we enforce it. Because there are tools to actually do automatic lineage detection, but I'll tell you one thing: they don't work always. They actually work for 80% of times or 90% of times. They give you false belief that you have everything, but you don't have everything. And then suddenly you have an ETL that doesn't exist. You have shadow IT effectively, shadow ETLs. You believe you have everything, but you don't, right? So don't believe in those tools. You can use them as kind of, let's start with that because I want to have something. That's fine. But you will not get everything. So you need to actually have a step in development cycle to ensure it's up to date, right? And we do this by enforcing, doing this before pull request on Git is accepted. All right.
Last question, if you want to pick it up.
Oh, yeah, I can maybe pick it up. Yeah, sure. Okay. Does all Spark jobs run on one and the same cluster, and does each task spawn a new cluster? How do you manage this? No, so you cannot run on one cluster. It will destroy the Spark. You can run maybe tens of jobs or maybe even hundreds of jobs, but you cannot an entire IT infrastructure on one cluster. It will just blow up. Your driver will just blow up. So before there was no good solution for that because you had to just dynamically manage your clusters. But now actually Databricks have this new thing called cluster pools, and that solves the problem to a degree. The issue is that you still the cluster pools only manages one cluster variant, so one version. But you still have a problem if you want to run some jobs on Spark 3 and some jobs on 3.1. You still have this problem. So you always will have to have some sort of orchestration tool to manage which jobs go into which cluster. And that's generally done on deployment. So you want to do this on the CI/CD. When you deploy the job, you actually know in the config file, it should run on this specific cluster version. And then in CI/CD, you dynamically bind these things. So this task run on this cluster, this task run on these clusters. That's how you should solve it in the long term, right?
Yeah.
All right, all the time I had, and you guys as well, you have to go to other rooms. The slides will be posted. So my name is there, my contact details, my Twitter, my LinkedIn. Reach out to me. I'm very happy to contribute to the community, help you out with your problems. So feel free to talk to me. And again, if you want to work with me or a cool project that I work with, work for DXC. We're doing really awesome stuff. We're like 100,000 plus 6,000 employee company, really massive IT provider, and our analytics platform department is really blowing up in size. So please work for us. We'll have awesome things to do together. All right. Thanks for listening, everybody.
Thank you.
All right.
Okay. You have to end the session on top of left.
I have to end it, or you have?
Yes. Yes.
Thank you, everybody. Take care.
Thank you, everyone. Cool.